Hello my dear students, I welcome all of you in my class. I am Dr. Dilwar Alom Khan, Assistant Professor from the Department of Chemistry, SS College, Hailakandi. I will teach you basically the chemistry. So, before going to the chapter, first of all, we should know what the chemistry means. In science, that is, chemistry is the branch of science which deals with the study of matter and its composition. This is the simplest definition all of you have studied already. Starting from your pen, this whiteboard, ceiling fan, your mobile phone, everything is made up of matter. So chemistry basically deals with the study of this matter and its composition. Now, the chemistry can be further divided into different branches. What are those branches? Already you may know these branches are inorganic chemistry, organic chemistry, then physical chemistry, and in certain cases it can further be subdivided into your environmental chemistry, pharmaceutical chemistry, biochemistry, industrial chemistry, like this. These are the different domains of the chemistry. So, in your syllabus of HS first year, the unit number 12, that comes under your organic chemistry portion. So, the unit 12, the name of the unit is Organic Chemistry, some basic principles and techniques. This is the heading of the chapter. That means you will learn about the organic chemistry, what are the basic principles, and the techniques comes under your organic chemistry. Is it clear? So, first of all, we should know what is organic chemistry. In your periodic table, all of you are very aware about one of the element that is called carbon. Another element you also know, that is hydrogen. So the compound of carbon and hydrogen are called hydrocarbons. The organic chemistry is the branch of chemistry which deals with the study of hydrocarbon and its derivatives. Means all those compounds which are formed from hydrocarbons are called derivatives of hydrocarbon. So organic chemistry deals with what? The study of hydrocarbon and its derivatives. Is it clear? The simplest example of hydrocarbon you may take, that is CH4. The name of this compound is methane. So this is an example of hydrocarbon. In this hydrocarbon, there is one carbon and 4 hydrogen. So if you replace one hydrogen by any other group, just as for example, if one hydrogen is replaced by OH group, it is called methanol. So this is a derivative of hydrocarbon called methanol. So the study of hydrocarbon and its derivatives are called organic chemistry. This is the basic definition, and in another way we can also define organic chemistry. This is the branch of chemistry which deals with the study of those compounds which are made up of what? Carbon, hydrogen, oxygen, nitrogen, halogen and phosphorus. Actually, this nitrogen, halogen, phosphorus, oxygen all are inorganic elements. So in certain organic compounds, the inorganic elements are also present. Just for the simplest example, you can take one of the example, CH3NH2. It is called methylamine. It is an amine group. So here you can see beside hydrogen and carbon there is an inorganic element called nitrogen. Okay. So inorganic compound, some means inorganic elements may be there. So hope what is organic chemistry, it is clear to everyone. Now before going to the details of this chapter, as this chapter deals with the carbon and its compound, so first of all we should know this is a symbol of carbon. What is the atomic number of carbon? Hope every one of you know the atomic number of carbon is 6. So if you write the electronic configuration of this carbon, 1s2, 2s2, 2p2, 6 electrons are there. So 1s2, 2s2 and 2p2, total 6 electrons. In your class 9th or 10th, you might have studied about the valence shell. So that is the outermost shell of an atom is called valence shell. So what is the valence shell of this carbon? That is the outermost shell, this one and this one, 2. So how many electrons are there in outermost shell? 2 plus 2, that is 4 electrons are there in the outermost shell. So what is the valency of carbon? 4. That means this is called the tetravalency of carbon. Now since the valency of carbon is 4, that means to complete its octet, we know for the stable configuration every atom has a tendency to complete its octet. Octet means 8 electrons in the outermost shell. That means to complete the octet, carbon requires 4 more electrons, and it completes its octet by sharing of its electron with other atoms to complete its octet. Is it clear? So on the basis of that, hydrocarbons are formed. So this is the tetravalency of carbon. Now you see how a bond is formed. We know covalent bond is formed by sharing of electron. Suppose an element is having 1 electron and another element is having another electron. When they share, they form a bond. So a bond is formed by the sharing of 2 electrons. So sharing of 2 electrons forms what? Single bond. If one pair of electron by each atom is shared, then it forms double bond. Similarly, you can get triple bond. Single bond, double bond and triple bond. So whenever you get a single bond, it is always what type of bond? It is sigma bond. That is formed by the head-on overlapping of atomic orbitals. That we'll discuss in the orbital concept later on. Now, when there are 2 bonds are there in a compound, that is double bond is there. So always there is one sigma bond. Suppose this one is sigma bond and one pi bond. So if there are 2 bonds, one is sigma bond and another is pi bond. Is it clear? Similarly, if there are 3 bonds are there, then one is sigma bond and remaining 2 bonds are called pi bond. Is it clear? So you can easily find the number of sigma bonds and pi bonds in a compound. Let us take one example that will make you the concept clear. CH3, CH2, CH3. Or if you write it like this, it will be easier for you to understand. CH3, CH2, CH3, CH2, CH3. In this compound, how many sigma bond and how many pi bond? Since all are single bond, so all will be what? Sigma bond. The total number 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sigma bond. Since there is no double bond and triple bond, so there is no pi bond. Another example. CH3, CH, double bond, CH2. Suppose this is another compound. Okay. So in this compound, how many sigma bond and how many pi bond? So sigma bond, see, all are sigma bond 1, 2, 3, 4, 5. Here 1 sigma, okay, 5. So 6, 7, 8. 8 sigma bond. And how many pi bond? We know pi bond exists only if there is double bond or triple bond. So here one double bond is there. So 1 is sigma and 1 is pi. So how many pi bond? Only 1 pi bond. Hope it is clear to everyone. Next, the topic is representation of organic compounds. That means how can we represent the organic compound? Representation of organic compounds. We can represent an organic molecule or the structure of an organic molecule in 4 different way. First one is called Lewis dot structure or simply dot structure. Dot structure or formula. Dot structure or formula. So what is dot structure? You see, this dot represents your electron. We know in case of carbon, how many electrons are there in the valence shell? There are 4 electrons are there in the valence shell. So we represent them as dot. So 1 electron, 2 electron, 3 electron and 4 electron. Okay. Now we know for completing the octet it requires 4 more electrons. Now again, a hydrogen atom has 1 electron in the valence shell. The atomic number is 1. So 1 electron in the valence shell. So we know every atom has a tendency to complete its doublet or octet to get the stable configuration, stable noble gas configuration. So hydrogen is having one electron. To complete its doublet, it requires one more electron. Therefore, this hydrogen will share its electron with the carbon. Similarly, another hydrogen will share its electron with carbon. Another hydrogen will share its electron with carbon, and one more electron will be shared by another hydrogen. This is the structure of methane molecule. By doing this, carbon had completed its octet. How? 2 electron, 4, 6, 8. Its octet is complete, and every individual hydrogen has completed its doublet. 2, 2, 2, 2. The methane molecule is now in stable configuration. This representation is called dot structure representation. If you take another example of ethane, 1, 2, 3, 4, this one carbon atom, like two, 3, 4. This is another carbon atom. Now for this carbon, you see 2, 4, 6 and 8. 8, that is octet is complete. Similarly, for this carbon, you can write now for this also octet is complete. 2, 4, 6, 8. This is the electron dot structure or representation of ethane molecule. Hope it is clear. This is called dot structure. Number 2, it is called dash structure, or sometimes it is called graphical structure, graphical representation. That means sharing of 2 electron by 2 different atoms makes a bond, and this is represented by, if you join this is just like a dash. Therefore, it is called dash structure. That means this dash represents a bond. Now, as we have written in case of methane molecule, the dot structure is like this. This is the dot structure, and if you join each pair of electron, they forms a bond. So dash, 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 dash. This type of representation is called dash structure. As for example, for ethene molecule, there is double bond. So double bond is formed by the sharing of one pair of electron by each carbon. For this carbon, 4 electrons are 1, 2, 3, 4. And for this carbon, 1, 2, 3, 4. 4 electrons there. Now, they will share a pair of electron, will form double bond. And remaining 2 electrons will be shared with hydrogen atom to form 2 bonds. Similarly, for this carbon atom also, so this is the structure of ethene molecule. This is called dash structure. Is it clear to everyone? Hope it is clear. third structure is the third type of representation is called condensed structure. Condensed structure. What is meant by condensed? To decrease its area or space, it is called condensation. Okay, means to minimize the space. That means, as we have seen in case of ethane molecule, suppose this is the ethane molecule. In this ethane molecule, while writing by dash structure, we required a lot of space, and it also requires more time. It's time consuming. So in order to save the time as well as space, we can condense this structure, and this is called condensed structure. How can we condense it? We will not show the bond between this carbon and hydrogen. That means we can write it like this. CH3 means with this carbon 3 hydrogens are there. So CH3, CH3. Now this space has been minimized and time is also saved. This is called condensed structure. We can further condense it. You can write it like this: CH3, CH3. So this is called condensed structure. We may take another example. CH3, CH2, CH2, CH3, CH2, 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 CH3. How many carbons are there? 1, 2, 3, 4, 5. So it is an example of pentane molecule. Now you see, we can write in condensed way, condensed structure. How can you write? CH3, then CH2, 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 CH3. 1, 2, 3, 4, 5. So this is the condensed formula of this one. We can further condense it. How can we can condense it? You look here. CH3. Then how many CH2 group are there? 1, 2, 3. Okay, 3 CH2 group. And again CH3. So we can further condense it into like this. So this type of representation is called condensed structure or condensed formula. And the last type of representation, that is fourth one, is called bond line structure. Sometimes we may call it skeletal structure also. So this is called bond line structure. That means here we do not write the carbon and hydrogen, only we represent it by line. How? You see, suppose this is a line. So whenever in organic chemistry such line is there, that means we have to understand that there are two carbon, one in this end and another is in this end. There are two carbon, and we know to complete its tetravalency it will require 3 hydrogen here and 3 hydrogen here. So basically this is your ethane molecule. So we can represent ethane molecule by only writing bond line. Is it clear? Similarly, if there is double bond. This is not bond but two lines are there. That means in this end there is one carbon, in this one there is carbon, and this carbon has already shared 2 electrons. So 2 remaining electrons will be shared with 2 carbon hydrogen, and this carbon will also share 2 electrons with hydrogen. So this is your ethene molecule. That means ethene molecule can be represented by bond line like this. Is it clear? Now another thing is there. In bond line, if there is 2 lines meet at a point, suppose this is one line and this is another line meeting in a point, this point also represents one carbon. So how many carbons are there? 1, 2, 3. Is it clear? Now this carbon has already shared 1 electron, so remaining 3 electrons are shared by hydrogen. Like this, here also CH3. For this carbon, 2 electron has already been shared with 2 different carbon, so remaining 2 electron will be shared with 2 hydrogen. So this is nothing but CH3, CH2, CH3, that is propane molecule. That means in bond line representation, a propane molecule is represented by like this. Hope it is clear. One more example. So you can easily say what is the name of this compound. That means the terminal carbon, if there is nothing is written, that means it represents one CH3 group. And in between, if there is no double bond, so each point angle represents one CH2 group. CH3, CH2, CH2, CH3, CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. So this is hexane molecule. This is a bond line structure. One more thing you can see here. In bond line representation, if nothing is written, then we consider it methyl molecule, CH3 group. But if it is mentioned any other group other than methyl, suppose OH, then there is no carbon here. Then we have to consider what is written, that is OH. So OH represents what? Your alcohol group. So this compound will be an alcohol. That is CH3, that is CH2, another CH2, and finally OH. So this compound will be 1, 2, 3, 3 carbon, that is propane, and 1 hydrogen is replaced by OH, that is called propanol. So naming we will discuss later on. So in this way also we can represent an organic compound. So these are called the representation of organic compound. Hope the 4 different types of representation is clear to everyone. Next we will go to another topic, that is classification of the organic compounds. In this chapter, your next topic is one more thing I have to show you before classification. all this structure or representation we have discussed is all about your two-dimensional structure. When you will in the further means higher classes you will study stereochemistry, there you have to understand about the three-dimensional structure of the organic compounds as well. For that, for the simplest example you can take that of methane molecule. What is the name of this one is? This is your methane molecule. So normally we represent it like this. In two-dimensional structure we represent it like this. But if anyone asks you to write in three-dimensional representation, then this structure varies somewhat. How we will write it? This is your central carbon atom. This will be more clear if we show you in three-dimensional way. Just for example, this is a notebook. So you see this is one plane. Okay. Now in this plane, if there is one carbon atom, C is placed at the middle. C is placed at the middle. And if two hydrogen are in the same plane, this is a plane. So in the same plane, two hydrogen, 1 and 2. Means in the middle there is carbon, and in the same plane two hydrogens are there. Is it clear? Remaining two hydrogen is, if you look it like this, C is there, one is hydrogen here and another hydrogen is here, two hydrogen. And remaining two hydrogen, suppose I am looking from here. So one hydrogen is towards me. If I am the viewer, viewer means I am looking towards the molecule. So one hydrogen is towards me and another is away from me in that direction. Is it clear? So that is a three-dimensional representation. So one is hydrogen is towards me and one is away from me. One is towards the observer and one is away from the observer. So these are represented like this. One hydrogen atom which is towards the viewer, it is represented like this. One hydrogen is here. This hydrogen is towards the viewer. Okay. And the one which is away from the viewer, suppose you are looking and the hydrogen atom which is away from you, this is shown by like this. So this hydrogen is away from viewer, it is towards the viewer, and the remaining two hydrogens are in the same plane. So this is the three-dimensional representation of the organic compound. Hope it is clear. And the last topic of today's lecture, that is classification of the organic compounds. Classification of organic compounds. That means how can we classify them into different classes? Is it clear? So you will write it like this. Organic compound, first it can be classified into two different categories. One is called acyclic compound or open chain compound, and another category is cyclic compound or closed chain, cyclic compound or closed chain compound. Okay, acyclic, that is open chain, that means chain is open, two terminal ends are there. And cyclic compound, there is no terminal end, it is ring structure. Okay, maybe triangular, quadrilateral, like this. So these are called cyclic compound. Actually we'll discuss in detail later on. So acyclic compound or open chain compound, or cyclic compound or closed chain compound. Closed chain compounds are also called ring compound. Now we can further classify cyclic or closed chain compound into two different categories. What are those? First one is called homocyclic or also called carbocyclic compound. Homocyclic or carbocyclic compound. And the remaining one, another category is called heterocyclic compound. Homocyclic and heterocyclic. Homocyclic means in the cyclic structure, since it is a cyclic compound, so the structure will be cyclic. In the cyclic structure, all the constituent atoms in the chain are of same type. We'll discuss later on by taking example just like cyclopropane, cyclobutane. Heterocyclic means if in the chain different atoms are there. Suppose 4 atoms are carbon and another one is oxygen. So this type of compound is called heterocyclic compound. Just I am writing the divisions, later we will discuss taking individually. Okay. This homocyclic and carbocyclic compound can be further divided into two categories. What are those? First one is called alicyclic compound and another one is aromatic compound. Alicyclic comes from two different words, that is ali and cyclic. That is aliphatic cyclic compound. So homocyclic compound can be aliphatic or aromatic. If it is aliphatic, then it is called alicyclic, and if it is aromatic, then it is called aromatic compound. Now you may ask, what is alicyclic, what is aromatic? We will discuss when we will discuss individually. Then it will be more clear to you. Okay. Now this aromatic compound can be further subdivided into two different categories. What are those? These are called benzenoid and non-benzenoid. Benzenoid and non-benzenoid. Benzenoid means benzene ring is there. Maybe 1 ring, 2 ring or 3 rings are there, but there must be a benzene ring, that is called benzenoid compound, aromatic compound. And if there is no benzene ring, then some cyclic compounds are there in which it is aromatic but there is no benzene ring. Those are called non-benzenoid aromatic compound. So this is the broad classification of your organic compounds. In the next class, we will discuss them individually and we will take some more examples to make it clear to everyone. Hope what we have learned is you have understood everything, and if there is still any confusion, we will sort out those confusion later on. So what we have learned today, we have learned what the chemistry is, what are the different branch of chemistry, what is organic chemistry, what is the valency of carbon, what is the tetravalency, how can we find the number of your means sigma bond and pi bond. Then we have learned how to represent an organic compound. Okay, 4 different types of representations are there. What are those? You have learned. You can easily go through again and understand. If there is confusion, you can ask later on. Then we have also learned what? The different classification of the organic compounds. Hope it will be helpful for you. So see you in the next class. Take care. Have a nice day.